So we are on theorem 2 on chord properties, which says the perpendicular from the center of a circle to any one of its chord will bisect the chord. So what is given over here? Given a circle with center O and radius R. Given a circle with center O and radius R. And PQ a chord in which OT is the perpendicular from center O to the chord PQ. So what has to be proved? To prove that PT is equal to TQ. To prove that PT is equal to TQ. So we do a construction. What we will do? We will join P to O and we will join Q to O. Alright, and then we will apply congruency and very easily we will be able to prove that. So I am going with the proof now. Proof. In triangle OTP and triangle OTQ, OP is equal to OQ, OP is equal to OQ. Why? Because they are radius of the same circle. So plural will use radii of same circle. Now next, OT is in both, this OT is in both, so OT is equal to OT, that is common in both. Then we have angle OTP is equal to angle OTQ, each 90 degree. This means triangle OTP is congruent to triangle OTQ by right angle, both sides hypotenuse, both are equal, and one of the common side is equal by RHS. This further implies PT is equal to TQ. PT is equal to TQ by CP, CT, C, corresponding parts of congruent triangle criteria. So that means every time whenever a perpendicular is drawn on a chord from the center, it is going to bisect that chord. So we move to the next theorem now. So children, what is the theorem 3? Theorem 3 says if two chords are equal, then their perpendicular distance from the center will be equal. In other words, equal chords of the same circle are equidistant from the center. Remember, if there are equal circles, like same exact circle down, and the chord in both are equal, then the same thing will apply. The distance from the center will be equal. So, once again, what is given? Given is a circle with center O and radius R, and chord AB and CD which are equal. Chord AB is equal to chord CD. OM and OT are perpendicular. OM and OT are perpendicular. And we have to prove OM is equal to OT. For this, we make a construction. For this, we make a construction. we will join O2C and O2A. Any one of, in both the chords, any one of the triangle we will complete. Now I am starting the proof. Now here we have to act smart. First thing is, since OM is perpendicular on AB, this implies that AM is equal to MB. Why? Just now in the previous theorem we studied that the perpendicular from the center on a chord will bisect that chord. That means if OM is perpendicular, then this chord is bisected. That means each will be equal to half of the original chord. So AM is equal to half of AB. Similarly, we can write, since OT is perpendicular on DC, this implies that DT is equal to TC is equal to DC by 2. Now remember, this is equation 1 and this is equation 2. Remember, initially only I said chord AB is equal to CD, or I can name it as DC. So their half will be also equal. Since they both are equal, so half of them will be equal. Now what is AB by 2? AB by 2 is AM. What is DC by 2? DC by 2 is TC. So AM will be equal to TC. Now let us try to see this. AB is equal to CD. Perpendicular is drawn, so this will be bisected. So AM is AB by 2. So if AB is 4 centimeter, AB will be 2. But AB is equal to CD, so this has to be 4 and TC has to be half of that, so it will be 2. So that means AB by 2 is equal to DC by 2. So now we can use congruency. In triangle OMA and triangle OTC. OA is equal to OC. Then angle OMA is equal to angle OTC, each 90 degree. Then AM is equal to TC. From equation 3, this implies that triangle OMA is congruent to triangle OTC by RHS. So this further implies OM is equal to OT by CPCTC. So which proves that equal chords are equidistant. Let us try to see once again from here. AB is equal to CD, it was given children. Now the perpendicular, what happened? The perpendicular bisected this chord. When the perpendicular bisected this chord, so both the chords are equal, so that half will be equal. That means AM is equal to TC. And then it is easy from here. These two sides are equal, isn't it? These two sides are equal, now half of equal chords. This is radius equal and this is 90 degrees. So by RHS both the triangles are congruent. So when the triangles are congruent, OM is equal to OT. Now we move to the next theorem. Now children, what does the theorem 4 say? The theorem 4 says chords which are at equal distance from the center, they are equal. So what does this means? It means that if AB and CD are two chords and OM is equal to N, that means the distance from the center, and distance means perpendicular distance, are equal, then the chords are equal. So what is given? Given is a circle with center O, radius R, two chords AB and CD. Two chords AB and CD. Then perpendicular on each chord, OM perpendicular to CD, ON perpendicular to AB. What has to be proved? And the perpendiculars are also equal. That means OM is equal to ON. So what has to be proved? AB is equal to CD. So construction, what we do? We join O to D and we join O to B. Now it's easy. So we now take up the proof. We take up the proof. What we do is we take up the triangle. In triangle OMD and triangle ONB. What happens? OM is equal to ON. This is given. OM is equal to N. OD is equal to OB. This is radii of the same circle. OD is equal to OB, radii of same circle. Then angle OMD is equal to angle ONB, E 90 degree. This implies that triangle OMD is congruent to triangle ONB by, now what is this? What theorem? By right angle, hypotenuse and common side. So by RHS. Now what this suggests? This will suggest MD is equal to NB. But if I multiply it by 2, 2MD will be equal to twice of NB. This is by CP I forgot to write. Now I multiply it by 2. Now remember, when the perpendicular is drawn, then the chord is bisected. That means MD is half of CD. In the other ways, twice of MD is equal to CD. So this is CD. And same way twice, because these two are equal. When the perpendicular is not, it bisects the chord. That means if this is X, this is X. So AB will be twice of NB. That means this theorem is also stated as equidistant chords from the center are equal. So we go to the last theorem. So we are at this is theorem number 5. It says equal chords subtends equal angle at the center. The theorem says equal chords subtend equal angle at the center. So what is given? AB, a circle with center O and radius R. Chord AB is equal to chord CD. To prove that, we have to prove angle AOB is equal to angle COD. We have to prove angle AOB is equal to angle COD. So we join A to O, B to O, C to O and B to O. Now proof is the simplest, this is the simplest congruency proof. In triangle AOB and triangle COD. See what will happen. OA is equal to OD. Reason radii of same circle. Then OB is equal to OB is equal to OC. Now OA is equal to OD, OB is equal to OC, same reason. And then chord AB is equal to chord CD. This is given. So by SSS, triangle OAB is congruent to triangle OCD by SSS. So this implies that angle OAB is equal to angle AOB is equal to angle COB, and this have to be proved. Thank you.